Hello everyone, welcome to Tech-Lavya. Please like, share and subscribe.
I have already discussed single phase induction motor and their types. Now today under this category we are going to discuss, not exactly in this category, actually the unit says that this is a single phase induction motor unit, but the last topic of this unit is a stepper motor. We have discussed AC motor, DC motor, isn't it? Induction motor. So you must have observed that here once the rotor starts rotating, it rotates continuously, isn't it? But stepper motor, the rotor does not rotate continuously, rather it rotates in steps, okay, discrete steps. Now I shall explain this with very simple example. Now suppose you have a wall clock, okay? Yes, so here you have a wall clock and here you have 12 o'clock, 1, 2, 3, 6, 9. Okay, so whether this is a minute hand or hour hand, it does not make much difference. What I wish to tell you is, see, you have total 360 degrees, right? Correct. And then suppose this hand moves from 12 to 1 and then from 1 to 2, then 2 to 3, right? So what is going to be the movement? Now total 360 degrees will be divided by 12, correct? So you will say that 1 hour, the movement of 1 hour, I am considering hour and denotes 30 degree movement, right? So when the clock hand moves from 1 to 2, what is its movement? 30 degree, right? So this is how actually stepper motor rotates. So once it rotates 30 degree, then after this again it rotates to 30 degree, then again it rotates to 30 degree and then stops. Okay, so this is how stepper motor operates. Now obviously instead of continuous signal we give pulses. Fine, so this kind of signal is given so that it first rotates to 30 degree, then stops, then again rotates, then stops. Now depending on the width of this signal, I can say that how frequently it will rotate. And this 30 degree is called step angle. Okay, step angle. Fine. Now I'll tell you a very fascinating example of the usage of stepper motor. Now you must have seen some robotic arm. And small children are very much fascinated by JCBs used for construction. They want a toy of JCB, correct? Now suppose if you also want to build such application, so you will be picking up some object, suppose you have a sorry yes so now suppose you have a conveyor belt, okay, and here you have many objects. What you have to do is you want to make the process automated. We all see such kind of videos wherein factory, how things are made in factory, these processes are shown. So there you have everything automated, correct? So here you have conveyor belt wherein many objects are placed, and here you have that robotic arm, okay, and these are two teeth. So what it does is it comes here, picks this product or object, again takes it back, then it turns and keeps somewhere else. Okay, so this sorting kind of arrangement, picking up, such type of applications are developed by stepper motor. Another very simple application could have been, if I want automatic water dispenser or automatic hand wash dispenser, that if someone takes his hand in front of the hand wash dispenser or water dispenser, after sensing the presence of hand, it you know turns that dispenser output to be on, and then again it becomes off. So definite quantity falls down, and then it becomes off. So every time, we need not touch it, or we need not have any control over it. So such automated applications are developed by stepper motor. So actually stepper motor is a very important kind of motor. Fine. And we are going to discuss the types of stepper motor after this, but first I would like to share how it works, and later, after that we will be discussing various types, because you first have to understand how does it operate. Fine. So here, just for your information sake, let me tell you that we are going to use two pole pair. It means two north pole and two south poles will be there. So total four poles, but actually they're not four poles, but they are two pole pairs. Okay, fine. And then there is one more category of stepper motor. You have single stack stepper motor, and you have multi-stack stepper motor. Fine. So we shall see now what exactly happens. So here we have stator, and here we have electromagnets. Okay, these are the poles. So these are the poles. So now you understood why I said two pole pair. Okay, fine. Now what we will do is, we will have windings on these poles. Fine. And this winding will be connected to this. Fine. So these are connected in series, but otherwise the circuit will be very complicated. So what I'll do is, I'll erase this so that it does not become very complicated. Similarly, I have windings here also, and again these two windings, the orange windings, are also connected together. Fine. Understood? Yes? Correct. So what I'll do is, let us name these poles. So let us name this, let us name these poles as A and A dash. Similarly, we'll name these poles as B and B dash. Fine. And now let us talk about the rotor. So here you have single stack rotor. So this is how it looks like. Okay, and this is made up of permanent magnet. This is called permanent magnet. So permanent magnet means what? It has north pole here and it has south pole here. Fine. So what we are going to do is, first we will energize pole B. Okay, first we will energize pole B. So the current starts flowing in B. Fine. So here it flows in opposite direction. So now because of this current, this pole becomes a north pole and this pole becomes south pole. Fine. So this becomes this becomes South Pole and this becomes North Pole. Now you can very well understand that here we have North Pole, here also we have North Pole, but here you have South Pole and here we have South Pole. So this South Pole of the stator pushes the south pole of the rotor because they will repel each other. So it moves in this direction. At the same time, north pole of the stator attracts the south pole, correct? So, and similarly, this north pole is attracted by this south pole. Got it? Yes. So let us see what will be the new situation. Okay, so I will not be drawing the whole assembly, but I shall tell you the arrangement here. So this was north pole, this was now south pole, and earlier my stator stack was like this, but now it arranges itself like this. Correct? So this is south, this is north. Got it? Understood? I hope you have understood now. Fine? This was clear? So see, first it was at this position. Correct? The north pole. This was first condition. Now after giving the pulse, the north pole shifts here. So this is the second condition. So how much is the turn? How much is the shift? 90 degree. So in this case, the step angle is 90 degree. Got it? Yes? Okay. So now let us understand what happens next. So now you can very well imagine. Now here you have stator. Now I will be drawing a simple diagram. Not to, because I don't want to waste time here. So now this was winding B, B dash, and A dash. Now first we energized B pole. Now what we will do is we will energize A pole. And my rotor stack is something like this, isn't it? So this was north and south, north and south. Now since I have given the power here, now this becomes, sorry, I shall write it inside it, yes. So this becomes now north and this pole becomes south. So now what will happen? This north pole will be attracted by the south pole and this south pole will be attracted by the north pole, isn't it? So how will be the new arrangement? The new arrangement will be like this. Correct? Now here you have south, here you have north. So earlier the position was this. After that the position became this, 90 degree. Now it has arranged itself to this position. It means another 90 degree shift was there. So what is the total shift? 180 degree. In the next part you will be exciting, you will be exciting this pole. Correct? So, continuously in this way the rotor keeps rotating. Understood? Fine. So this was single stack permanent magnet stepper motor. Now why is it called a permanent magnet? Because the rotor single stack material was made of permanent magnet. So north pole and south pole are permanently there. If we wish, we cannot change it, right? So it is already there. Fine. Now let us talk about the working of multi-stack stepper motor. Now what is the meaning of multi-stack? All other things will be the same. Okay? All other things will be the same. But here, for multi-stack stepper motor, the rotor is made up of ferromagnetic material. Okay, we have seen what is ferromagnetic material in class 11th and 12th. Ferromagnetic materials are which gets attracted by magnets. So say iron. The simplest example can be iron. Okay, now we are not going to use permanent magnet. Secondly, since it is a multi-stack, here you have such kind of arrangement. The simplest being this. You can have multiple number of stacks. Another thing is here now we will have 6 poles. It means it is going to be now 3 pole pair. Okay. Yes. See, we have all the diagrams, but when I draw this with my own hands, I find it easy to explain. Okay, so here you have A, opposite is A dash. Similarly, you have B, opposite is B dash. And similarly, you have C, and this is C dash. And you have windings here, correct? So this is understood that you have windings here. Similarly, you have windings on B and C also. Okay, so what we are going to do is we are going to energize pole pair A. It means current is given to pole A. So because of this becomes north pole and this becomes south pole, correct? Now see, to this north pole, which stack is very close? This particular stack is very close, isn't it? And this is made up of ferromagnetic material. So this gets attracted and moves towards north pole. Similarly, this particular edge is close to south pole. So this also moves towards south pole. Okay. So earlier this was the arrangement, correct? I shall draw it properly now. Earlier it was arranged like this. Now it has moved to this new position. And this shift is actually 30 degrees. Fine? Okay? Yes. So here is our stator. Next part, we are going to see the next thing. And yes, this was the case. Now what is going to be the next case? Tell me. We had energized A here, correct? So what we are going to do? Now the new position of the stack is something like this. Correct? It is something like this now. So what we will do is we will energize the next coil. So it further moves. Correct? And then we will energize the very next coil. Then again it moves. The process is simple, but one by one we are energizing different poles. Okay, we are giving the supply to one pole or one winding at a time. So this stator winding, rotor poles are, moving in different steps. So they actually get attracted by the corresponding north pole or south pole, and in that process they move to 30 degrees. Okay, understood? I hope this is very clear to you now. This was all about stepper motor working. Now let us talk about the types of stepper motor. There are two types of stepper motor: variable reluctance stepper motor and permanent magnet stepper motor. Now permanent magnet also we have seen. Now we shall understand what is variable reluctance stepper motor. Actually we have seen that, but we just have to discuss that why it is known as variable reluctance stepper motor. So first let us understand what is this reluctance. Now we all are familiar with the word resistance, isn't it? We all are familiar with the word resistance. Resistance, what is the value of the resistance? It opposes the current. So basically reluctance opposes the magnetic field. Okay, it opposes the magnetic field or flux. So see, this was the stator and here we had rotor, right? And here was our north pole. Correct? Don't mind the drawing. No, this is wrong, so I shall draw it again. Yes, correct. So this was behaving as a north pole. So in between you have air, right? So here you have air gap. So basically this air gap resists or opposes the magnetic flux. It means here you have reluctance because air gap opposes the magnetic flux. So when this moves, it means now this is made up of ferromagnetic material. And what is the property of ferromagnetic material? They are attracted by the magnets. It means they support magnetic flux. And the very big advantage of ferromagnetic material is magnetic lines of forces go inside the ferromagnetic material or they pass through the ferromagnetic material. Okay, so it means earlier there was an air gap, but when this moves, okay, because of this movement the reluctance is changing. So because of this factor, this type of motor is known as variable reluctance stepper motor. And we have seen that if this is made up of permanent magnet, it means that in variable reluctance stepper motor we use ferromagnetic material. And if the same is made up of permanent magnet, then it would be called as permanent magnet stepper motor. Fine? Yes. So this is how it looks like. Now see, this is a proper diagram, but I explained it with the diagrams which were drawn with my hands only. So see, these are the coils. Okay, so we discussed about these coils and see these coils are connected. Okay, and here you have number of poles in the rotor. Now simplest being 4 poles or 2 poles or 1 stack or 2 stack. I explained it with those examples. Here you have 1, 2, 3, 4, 5, 6 poles or 6, 3 set of stacks. So that is okay, but the operation remains the same. Fine. So see, earlier the situation was like this. This was 1, isn't it? This was 1 and here was 2. And then this particular pole moves to this position, correct? So now this becomes 1 and this becomes 2. So this is how stepper motor moves in small steps. Fine, I hope you understood this. So this is the internal structure. So we have switches. So as I said, that one by one the supply is given to one winding at a time. So actually we operate switches. So at a time only one switch is closed. So since there are 4 poles or 2 pole pair, we are using 4 switches. So one switch is closed at a time and all other 3 switches remain open. So one winding receives the supply. Fine? Yes. So basically this is how it operates. Okay? Fine? So what we are going to do is, yes. So this was the same condition, correct? It is moving step by step. Then you have permanent magnet. So in permanent magnet, see, north pole and south poles are written. And if you compare here, 1, 2, 3, 4 is written. So we have not written, north pole and south pole. Otherwise it would show that it is a permanent magnet. Fine. So this is how they look like. So this is 90-degree shift. So see, here it is 0, then 90, then 180, 270, and then comes back to 0 or 360 degrees. So this is how it works. Now let us talk about the step angle. Okay, step angle. Now step angle is decided by, step angle means what? By what degree does that move? That is very important, because if you want, just to operate the opening of the water dispenser or soap dispenser, you might require it to turn by 90 degree. But if it has to pick up some object and then collect it, and it has to rotate, place it at a particular point, then it might require very minute step angle as low as 1.8 degrees. Yes, even 1.8 degree step angle, achievement of 1.8 degree step angle is also possible. So that step angle is very important. So that step angle is decided by the equation ns minus nr upon ns into nr into 360 degrees. So ns are the number of stator poles and nr is the number of rotor poles. Okay. Now please remember that these can never be same. Otherwise the numerator would be 0 and the step angle would be 0. Fine. So let us just take an example that let ns be 50, which is very popular. I am taking a very popular case here. So nr will be 2 less than that. So my step angle, either it could be represented as alpha or it can be represented by beta also. So it becomes 50 minus 48 upon 50 into 48 into 360. So now you calculate what is the step angle for this. Come on, quickly do the calculation. But it has to be in degrees. Okay, now you can find out by your own, but it is in degrees. You have to convert it into degrees. Fine. Well, so I want to discuss one point here. Let us go back. Yes, I want to discuss this particular diagram now. Okay, so what we are doing is, first we are energizing B. Okay, first we are energizing B. So this becomes North Pole and B dash becomes South Pole. So which pole is closest to this? This. So this gets attracted towards North Pole, and see, this is the new position. This aligns itself to the direction of B and B dash. Okay? Fine. So now you have a truth table kind of arrangement wherein you have poles as ABC and the step angle. So what we are doing is, we are not giving anything to A, we are not giving anything to B, but we are making B as positive. When we make B as positive, the pole or the rotor shifts by 30 degrees. Correct? Is it right? Yes. Okay, so this is the new position. Fine. This particular position is the new position. Now what we are going to do is, we are going to energize now C. First we energized B, now we will energize C. So see, this particular pole is closest to C, and now it will align itself in this direction. So what is the next line in the truth table? A is 0, B is 0, but now C is made positive. So we get another step angle of 30 degrees. Correct? And then after this, we will make A positive. So now this becomes North Pole, this becomes South Pole. Correct? So if this is energized, now this combination gets attracted. So it aligns itself in this direction. So now A is positive, B is 0, C is 0. So we get another 30 degrees. So what is the total phase shift? 30 plus 30 plus 30, 90 degrees. Understood? Correct? So in this way, stepper motor operates. I hope this is very clear to you. This is a very important question for your exams. Study well, and we shall meet soon.